loaded memory is reasonably minimalist. It just contains a kernel, drivers, critical state files, etc., system, that sort of thing. Just enough to sort of actually load everything up, load all the device drivers, gain access to all the hardware, find the real root file system, at which point you get access to everything else. You're doing a live boot or an installation, you don't have a real root file system underneath. So you've got pretty much everything goes into this boot archive. And it doesn't depend on anything. Actually, sort of Smartos, which is one of the other sort of Illumos variants, is rather different from this. Its regular boot is everything into memory, and no disk, no nothing. So that's what's in the platform area. The only other thing, the zlib files. Now, in most of the OpenSolaris style distros, you'll see one, well, you'll see two in most. I only have one. Solaris.zlib is actually the user file system. So you get user from Solaris.zlib, everything, most everything else is embedded in this root archive. If you have Solaris.zlib, then sort of that's basically it's really all useless junk that sort of you didn't actually want to put anywhere important. So /opt, I think, goes there. Yes. It's got stuff in it, but it's not needed for boot. It's not critical. So if you lay down your system properly in the first place, you don't actually need this. I say, Smartos doesn't bother. One big root archive. Yeah. So I say it's a file that expands into the user file system. So what it is, it's actually just like another ISO image. It's a HSFS file system in a file, just like an ISO image. It's Lofi compressed, so Lofi, the loopback file mechanism, allows transparent compression and uncompression, which means that you can have this thing compressed on the disk, stick Lofi in front of it, and it'll automatically sort of output the sort of raw uncompressed data. There's, you can use gzip, either regular gzip, gzip 9, or LZMA. Those give you a tiny little benefit in terms of the amount of space that you save, and a horrendous hit in terms of performance. Back in the day, I don't know if you remember, there were actually two OpenSolaris images. There was the regular one and an all languages one. The all languages one was compressed just a little bit harder so it would fit onto a CD. God, it was slow. I'd say all you do basically is you take this file, throw Lofi at it, that exposes a device, you mount that device on /user. The interesting trick at this point is actually finding Solaris.zlib. Grub has pulled your kernel and your boot archive off the media. At this point, and dumped into memory and transfer control, at this point it has no memory whatsoever of where they came from. There doesn't seem to be a mechanism to actually pass the location through. So what the system has to do is basically, it's sort of running in this sort of minimalist environment with no user file system. It has to go around every single device that it can find, saying, is there a HSFS file system on this thing? Has it got Solaris.zlib on it? And that's where this .volsetid file comes in as well. Because somebody thought, well, what if somebody's got multiple devices attached to this system? What if they've got multiple CDs? What if they've actually got some sort of, they've actually created a file system that's got a file called solaris.zlib on it. So we better make sure we find the right one. So what you do is you've got this dol.volsetid file. There's a copy of it on the ISO, on the CD, and there's an identical copy embedded in the boot archive. And you go through, search through all the devices, look for the solaris.zlib, look for this .volsetid, and you verify that they're the same. And it's just, in fact, all I do is that's just an MD5 hash of the release number. It's nothing complicated. It's just random. It doesn't matter as long as it's unique. This could cause merry hell if you actually run this thing as a real system, which some people have managed to do, is to actually have this sort of layout installed on a real system. It goes crazy because you can't find various things. And that's what that file is. So to mount user, you basically enumerate all the devices, match.volsetid. It's got solaris.zlib. So Lofi ADM on that, then mount /user from it. You can actually just do a straight mount these days. You can actually just say mount file system. You mount this file as a file system, and it will call Lofi automatically. That doesn't work here because that doesn't allow you to sort of mount secuid root file systems, which /user is. So it has to be done in separate steps. Turns out you actually need some files from /user in order to make this all work. Nobody has really documented which files from /user you need in order to do this, because basically there's this enumerate devices match.volsetid. You wouldn't do it on the normal system, so the split as to what's in sort of /lib or /sbin, and therefore the root file system, or what's in /user is set up for a regular system. A live system is slightly different. So for instance, you actually need things like FS type and some of the TempFS drive, TempFS module for that, the HSFS module for that, so that you can actually go out and identify these things. But once you understand that's what it's doing, and you read the scripts, you can actually go through and sort of work it out. If you get it wrong, basically the system will either spit an error message saying you can't find anything, or it'll just hang. The worst thing is when it just hangs and you have no idea what it's doing. As an aside, you can also, you don't have to boot off an ISO or a CD, you can actually boot off the network. So x86, it's Pixie. Pixie boots off the network, gets DHCP, talks TFTP to something, loads Pixie grub. So basically loads grub. It's a different grub this time, but it's still basic grub. I'm sure you could use other mechanisms, but I'd managed to get this to work without too much pain, and it pulls down menu.list from your TFTP server. And then it grabs, again, the kernel and the boot archive from your TFTP server. It manages to grab those all from the same place. Now, there's no actual media, and again, it's actually lost completely where it came from. And this idea of enumerating all possible devices, well, you can't have it enumerating all possible servers on the network looking for where it might get a copy of Solaris.zlib from. But the thing is, you can see, we're on the server. We've set this up as a boot server, so we know where we went and put Solaris.zlib in the first place. So we can actually add that to the boot, the kernel line in the menu. So it's just sort of -b is arguments to the kernel, to the boot. Install media equals some location that happens to have Solaris.zlib in it. And then that grabs it. And one of the things we have to do is we have to add something into the sort of skeletal /user file system of the boot archive that's smart enough to be able to get this thing off the network. You could use NFS, I'll get to that. So we add wget and all its dependencies. We could add curl, but it's a bit bigger and it's got more dependencies, so wget is easier. So it sort of sticks Solaris.zlib on the end, wgets it off the network, copies it into /ton, same procedure, Lofi Adam, mount it. And off it goes. And it's actually very, very quick. It's far quicker running this way than off the CD, because once you've got this thing into memory, it just flies. Turns out the next game is sort of actually parsing boot arguments from user space, which took me a little while to work out. Then I sort of, Robert pointed out how to do it properly. Something I hadn't appreciated. So actually, if you just run prtconf -b/devices, it'll show you a lot of junk. But it'll also show you all the boot arguments, all the things that you might see out of EEPROM and that sort of thing are actually in there. So when we get to the demo, we'll try that. Different one else as well too. And then you sort of basically parse the output from that, looking for the string you want, or said horrors. Yeah, that means you need org and sed on the. Well, there's this thing called devprop, which Robert pointed out to me, which obviously somebody at Sun got fed up of doing this prtconf org sed chicanery and sort of wrote a command that we put on the root file system that actually did all that for you. So that's what's there. How do we actually make these things? First, you lay down an OS image somewhere. It doesn't matter how you do it. You could use IPS, SVR4, tar, just as long as you've got a copy of the OS installed, there, laid down on disk to manipulate. Yes, for instance, SmartOS just use the output from the Illumos build. They just tar that up. No packaging, no nothing. That's all they do. So this is how we make the boot archive. We create a file, match it up with Lofi, find the raw device, and then it's a UFS file system, right? So we UFS it, very easy. Going back a little bit, we have to sort of fix on the size for this thing. So this is an experimental thing. You know roughly how big this thing needs to be because you know how much you're going to copy into it. You want to make it a little bit bigger so that you've actually got room to maneuver once you've actually booted. If you actually had to install an extra driver, which you can do, or something like that. But you don't want to make it too big because it's mounted as a RAM disk. It's chewing up that fixed amount of memory, no matter what. So, sort of work out how big it's going to be at sort of 10 or 20 meg, and that'll be fine. But we can be reasonably efficient. We optimise for space. We don't give ourselves any of this sort of, what's it called, root reserve or whatever. We don't need any of that because it's only root is going to be using this thing, so we don't need to reserve space for anything else. We can optimise the number of bytes per inode. If you take the defaults, you chew up sort of 10 or 12% of all your space allocating inodes.